Section 9.5 is called the law of sines. So you might remember some time ago, I forget what section number it was, we learned how to solve right triangles. So let's do a quick review of that. So I'm going to draw a right triangle here. And we're told that this angle right here, angle A, is 47.8 degrees. And so this would be side A. Remember that angle A and side A are always opposites. We're told little b is 12.7. And what we want to find is we want to find angle big B. And we want to find little a. And we want to find little c. Those are the things we don't know. All right, well, angle big B is easy. That's this angle up here, of course. Big B is 180 degrees minus 90 degrees minus 47.8 degrees. 180 minus 90 minus 47.8 is 42.2 degrees. Okay, now we want to find maybe little a next. I know big A. I'm looking for the opposite, and I know little b, which would be the adjacent. So I've got angle, opposite, adjacent. That's tangent. So I would have tangent of 47.8 degrees is a over 12.7. So by multiplying both sides by 12.7, I can find a. 12.7 tangent 47.8. We'll call that 14.0. Okay, and then little c. Little c, what I would do is I have my angle, I have adjacent, and I'm looking for hypotenuse. So that's cosine. Cosine 47.8 degrees is 12.7 over c. So I would multiply by c, get that up here, and then I'd have to divide by that cosine. So 12.7 divided by cosine 47.8, 18.9. And units on these would be centimeters. Okay, so that's what we did earlier in the semester. What we're going to talk about for this section and the next section is what about triangles that are not right triangles? Many triangles in the world are not right triangles. How do you solve those? We have an issue in that we won't be able to use like opposite over hypotenuse or adjacent over hypotenuse because they won't be right triangles. That only works in a right triangle. So we have two different methods. One is called the law of sines. That's what we'll do in 9.5. And the other is called the law of cosines. All right, so let's talk about this law of sines and how it works. So I'm going to draw a triangle here. This triangle is not a right triangle. I'm going to tell you that right now. So I'm going to call this A. This would be side A. I'll call this angle B. So this would be side B. And this would be angle C. So this would be side C. Now, the truth is, which one you call A, B, and C doesn't matter as long as you have them as opposites. Big A, little a. Big B, whoops, little b. Big C, little c. They've got to be opposites of each other. All right, now what I'm going to do is I'm going to, in this triangle, I'm going to draw this, making a right triangle, and I'm going to call this H because that's the height of this triangle. So now notice what I can do. Now I can use the fact that I have a right triangle. I can say sine of A is opposite over hypotenuse, H over B. Which means H is B sine A. And then I can do the same thing using this triangle over here. Got another right triangle. I can say sine of B is opposite over hypotenuse. Sine B is H over A. which means H is A sine B. So since this is H and this is H, these have to be equal. B sine A has to equal A sine B. I'm going to take this equation and I'm going to divide both sides by A and B. On the left-hand side, these B's reduce out. I get sine A over A. Over here, these A's reduce out. I get sine B over B. And this is known as the law of sines. That in any triangle, the sine of A over A is equal to the sine of B over B. And furthermore, I could draw the height this way. I could have drawn it this way. Make a perpendicular up here and come down this way. And I could have gotten similar ratios, and I could show that this is also equal to sine C over C. All right, so this is our law of sines. I'm going to write it down here, and then we'll do this problem. I kind of ran out of space here. Sine of A over A is sine of B over B is sine of C over C. And sometimes this is written as A over sine A is B over sine B is C over sine C, depending on what you're dealing with. So it's nice to have these both ways. The way I tend to use it is if I'm looking for a little letter, A, B, or C, I use these because I like to have those on top. If I'm looking for a big letter, A, B, or C, I use it this way because I like to have the big letters on top. Okay, so here we go. We have B is 15.7, big A is 42.5, and big C is 56.8. Well, right away, I had trouble saying that, I can find big B. Big B is 180 degrees minus 42.5 degrees minus 56.8 degrees. Same as we did up above for this one. The angles have to add up to 180. That rule still applies. 180 minus 42.5 minus 56.8 is 80.7 degrees. All right, so I found big B. The other things I need to find is I need to find little a and I need to find little c. The key to the law of sines is that you have to have a pair. What I mean by that is, notice right now we have little b and big B. That's what I mean by a pair. You've got to have two of the same letter, one big, one little. So if I want to find little a, I'm going to use this. So I'm going to have little a over sine of a, sine 42.5 degrees equals, and here's why I need a pair. I need to be able to plug in both of these numbers. 15.7 over sine 80.7 degrees. So to get the little a by itself, I would multiply by sine 42.5. So I'm going to take 15.7, if I can type it in correctly, 15.7, there we go, times sine 42.5, and then divide it by sine 80.7. And we'll call it 10.7. Yeah, 10.7. Since we had 3 significant digits here, we'll go with 3 significant digits. Finding little c is almost the exact same thing, except now I'm going to use c over sine c. So c over sine 56.8 degrees is still b 15.7 over sine 80.7 degrees. And again, to get c all by itself, I simply multiply. So I'm going to use the power of my calculator instead of typing it all back in. The only thing that changes is this 42.5 changes to a 56.8. So I can just go back and have that type in, and we'll call it 13.3. Now, a nice little check, if you will, built into these is that B is the biggest angle, so side B should be the biggest. A is the smallest angle, so side A should be the smallest. It'll always work out that way. All right, let's try another one here. We have little b being 362.2, little c 394.6, and big B being 110.63. Again, the key is that I have a pair. I've got a little b and a big B. That will allow me to solve for big C. So I'm going to use this version of the law of sines because I'm looking for big C, so I want the sine up on top. So I'm going to have sine of big C divided by little c, 394.6, equals sine of B, sine of 110.63, divided by little b, 362.2. All right, so notice to get the big C, I've got to multiply by the 394.6, and then I got to get rid of the sine by doing the sine inverse. And again, I recommend you don't write any of this on your paper. I recommend you just use your calculator. So I'm going to have sine 110.63 multiply by 394.6, and then divide by 362.2, get that answer, and then do sine inverse of that answer. And you get error domain. Okay, so this is one of the realities about having triangles that are not right triangles. Sometimes, for the information given, there simply isn't an answer. And this is how you know you're not going to have an answer, when you get error domain. It doesn't work. Okay, so that is an unusual possibility, but it is a possibility. So what's happening here is this angle B is a big angle, like so, and this is angle B, and little b is up here, and big C is over, little c is over here maybe. What's happening is this B, this little b, really isn't long enough to be able to connect this point with that point. And I knew right from the beginning that that was going to happen. The reason I knew right from the beginning is that big B has to be the biggest angle because it's more than 90 degrees, which means little b has to be the biggest side. So C being bigger can't possibly work. Okay, so you might see that in your homework. Again, when you're going to know is when you try to do that sine inverse and you get error domain. Okay, got to pause this video, and then we'll finish this off with the next two problems in the second part.